Hello guys, today we are doing something very interesting and wonderful. We'll be looking today at how to balance any redox reaction on earth. Now, let's look at this. If we have manganese oxide, manganese oxide plus iron to give me iron plus, let's look at this. This is a redox reaction. Once I can prove to you again that it's a redox reaction by calculating the oxidation state. Simple as that. By calculating the oxidation state, I can prove to you that this is a redox reaction. Now let's calculate the oxidation state here just for fun, so that some people should know our overall charge. They watch my previous video, you see overall charge, you don't know. Let's do something that is having overall charge now. Let's calculate the oxidation number for manganese here. Because we don't know if we say it is X. For oxygen, we know it. Any element that contains oxygen, the oxidation state of or oxidation number of oxygen is -2 plus 4. 4 of them are there. That is -2. The sum of oxidation number of a compound is equal to the overall charge. The overall charge is -1 is equal to -1. Are we see? So it will be x. This time it will give me -8 equals to -1. X will be equals to, you carry this one this side, is -1 plus 8. X will be equals to +7. So the oxidation number for manganese here is +7. Look at the oxidation number for manganese here. Manganese, any element that is charged, the oxidation number of that element is the charge of the element. So the oxidation number for this, because it's charged, is +2. So manganese left from +7 to +2. It has been reduced from a bigger number to a small number. So manganese has been reduced. This one left from +2. Any element that is charged, the oxidation number is the charge of the element. It's just charged. So the oxidation state is +2. This one is charged, the oxidation state is +3. So iron left from +2 to +3. Iron left from +2 to +3. It has been oxidized. Are we there? Now, this has been oxidized. This has been reduced. Reduced. Are you seeing? So you see, a redox reaction is taking place because oxidation and reduction are taking place at the same time. That wasn't our purpose for this reaction. Our purpose for this thing was to balance it. How to balance redox reaction? We balance redox reaction like this. One, good note. We balance oxygen using water. But remember, as I'm balancing oxygen using water, I am putting hydrogen there. We balance this hydrogen when we wanted to balance this thing. We balance hydrogen using acid or proton. A proton. What is a proton? A proton is an acid. An acid is a proton donor. What is a proton? A proton is hydrogen without its electron. Look, hydrogen got one electron, this is just hydrogen. If it lost this electron, the number of protons becomes, see, hydrogen here is one proton, one electron. Are you seeing? So it's neutral. If it lost this electron, only a proton will remain. That's why we call H plus a proton, which is an acid. Keeping that aside, I said we balance oxygen using water, we balance hydrogen using proton, and we balance charges using electrons. Keep this thing in mind, then we are sorted. Go. Now, let's look at the reaction. We have manganese 4 oxide to manganese. I will take you guys to electrolysis so we know which one is cathode reaction or anode reaction from here. Watch my videos. You get this. So let's balance this one. First, we balance it as a normal equation. How many manganese are here? 1. How many manganese? 1. So manganese is balanced. How many oxygen? 4. How many oxygen? 0. I said we balance oxygen using water. So you can't come and add water on the side that is already having oxygen. So it is plus water. Because I want to introduce oxygen to this side so that it can be balanced. Are we there? Now let's look at this again. So let's balance our oxygen now. Because I've added water, I've already added oxygen and hydrogen. So something is also wrong. Let's balance it as our normal equation. Manganese 1, 1, oxygen 4, yeah, and 1. So we put 4 here. Now we have balanced oxygen. Because we balanced oxygen, we added hydrogen. So we balance hydrogen using acid or proton. We can't come and add the proton on this side because the hydrogen is already on that side. So we add it on this side. Plus H plus. How many protons are there? And how many hydrogens are there? This times this is 4. So we put it here. Remember, we don't balance the front here. That's it. Now remember, we are also adding charges. As we are adding charges, we balance charges using electrons. First, let's balance our normal equation. Manganese is 1, manganese is 1. Hydrogen is 4, hydrogen is 4. And hydrogen is 8. Oxygen is 4, oxygen is 4. Can you see that? Let's go now to the charges to see their balance. Now, this times this will give me 8 proton. 8 protons. Which proton is positively charged? 8 protons. 1 times this will give me negative 1 electron. Are we there? So let's add it. This plus this, negative 1 plus is 8, ne? Plus 8. This times this is 8. Negative 1 plus 8, big number, different sign. Take the big number from the smaller number and give the sign of the biggest number. So it's plus 7. Are we there? So the overall charge on the left is plus 7. Let's look at the overall charge. This times this is plus 2. This times 0 is 0. Plus 0. So the overall charge on this side is plus 2. Plus 2 plus 0 is plus 2. So it's not balanced. The overall charge on the left, the overall charge on the left is plus 7. The overall charge on the right, overall means adding everything, is plus 2. So the charges are not balanced. I said we balance charges using what? Electrons. Look at something with charges. Remember, they are positive, eh? Electron is negatively charged. So most learners will be confused. Do I add the electrons here or do I add the electrons here? Definitely you can't add it here, because if you add, and how many electrons will I even add? That's the problem. I want the charges to be balanced. If I put 5 electrons here, which is negatively charged, this positive will cancel with this 5, we'll have 3 electrons here. Are you seeing? Which is wrong. If I put the 5 electrons here, we'll have what? This will cancel with this, we'll have 2 protons, which is wrong. So where will I put my electrons? Please, this is wrong. I have to put my electrons where the charges is too high, where it's too positive. So this is too positive, this is too positive. Plus 7 is more than this. So I put plus 5 electrons on this side. Plus 5 electrons. Are you seeing? Plus 5 electrons. So these 5 electrons cancel with this, or have an overall charge here. You see, 5 electrons minus 5 protons will have an overall charge of plus 2 protons, which is also plus 2 here. Do you see that? If you still don't understand it, these 5 electrons will cancel here. We will have only 2 positive charge remaining, which is this one. So have plus 2, plus 2. So charges are balanced now. Let's look at the redox reaction. Let's look at the redox reaction. Let's look at the redox reaction. This manganese is 1, 1. This times this, 8 proton, 8 acid, 8 hydrogen, 8. What about the overall charge? The overall charge here is plus 2. Nothing is here, so it's plus 2. The overall charge, this time this is minus 1. This time this is plus 7. Plus 8. This plus this will give me plus 7. Plus 5 electrons. This and this negative, and plus 7, 5 electrons. Electrons are negatively charged. This minus this plus this will give me plus 2. So the overall charge here is plus 2. The overall charge here is plus 2. Charges are balanced. Finally, let's balance ion. Ion is moving from ion 2 plus, ion 2 plus to ion 3 plus. Are we there? So we balance charges using electrons. Where do we add it now? Okay, let's balance the normal equation. How many ions are here? 1, 1. Ion is balanced. Let's balance their charges. Plus 2, plus 3. Charges are not balanced. So we have an overall charge of plus 2 and and a ratio of plus 3. Charges are not balanced. When do we add? We balance charges using electron. When do we add it? To the side that is more positive, which is this one. Plus 3 is bigger than this. So plus, how many electrons do we add? Only one. Plus an electron. This one electron will come here. It will cancel one positive charge. How many remain? Plus 2. So charges are balanced. Now the charges here, they are balanced. Let's write now the overall equation by adding this and this. Because remember, it was this and this to give you this. So we balance it. So look at this something. We want the electrons to cancel at the final equation. Overall equation. Overall equation. When you look at overall equation, when you look at the overall equation, we have to add this and this, add this and this, add this and this. Make sure these electrons, they cancel. Look at this nicely. I will multiply this equation. I'll multiply this equation by 1, multiply this one by 5. Are we there? So this all through, 1 times this remains this, 1 times this is 8, 1 times this is 5, 1 times this is this, 1 times this remains this. You multiply all through by 5. 5 times this is 5, 5, 5. Are you seeing? So when we add in now electrons, we cancel. This electron is on the left hand side, this one is on the right hand side. These electrons will cancel. Can you see that? Then we add in now. Electrons are no more in our reaction. We add this one. Add left hand side is manganese 4 oxide plus 8 this plus this 5 F2 plus to give me, add right hand side this plus this to give me M2 plus 4 molecules of water plus 5 F3 plus. That is the overall equation. So let's see whether this overall is balanced. Please, I will permit me to wipe up there and then write this one there. Now we see whether it's balanced. Okay, I'm writing this equation up there. So we have like this. Want to check if everything is balanced. Okay, let's see if it is balanced, guys. And then it will be a perfect equation. How many manganese are here? One. Manganese is balanced. How many oxygen? This times this is 4. This times this is 4. Oxygen is balanced. How many hydrogen? This times this is 8. 4 times 2 is 8. Hydrogen is balanced. How many iron? 5 iron. 5 iron. Iron is balanced. Let's look at the charges now. Let's look at the overall charge. Minus, here is minus 1. Plus, this times this give me plus 8. Plus 8. This times give me plus 10. This times this is plus 10. Plus 10. Please, we are putting plus. So, is plus 8 plus 10 give me negative 1 plus, this plus this will give me plus 18. Are we there? Plus 18 times this will give me a total charge of plus 17. So the overall charge here is plus 17. Are we there? Right? Let's look at the overall charge here. This times this is plus 2. This times this 0 is plus 0. And this times this is 15. 5 times plus 3 is 15, is plus 15. Plus 15. Positive 2 plus 0 give me positive 2 plus 15. Plus 15 give me plus 17. So we have a total charge of plus 17 and a total charge of plus 17. We are good.